10.4 is not going to be a long section. That'll be a very short one. In fact, what I think I'm going to do is I think I'm going to send you a video link to it and send it to your email. So you guys need to watch that for next time. There will be a short assignment off of 10.4 at the end of that link. And so it won't be a long video, and the assignment won't be very long either. And I don't think you're going to find the assignment very difficult. But if you do have trouble, of course, you can ask next time. So, change of plans, we're going to roll right into Chapter 10, Section 5, where we look at a little bit different kind of problem. We're going to look at what I'm going to call or problems in this section. So that's one of our big issues that we'll discuss. And the other issue that we'll discuss is something called a complement. Sometimes it's easier to do a accounting problem by coming through what I call the back door. And that's the notion of using a complement. We'll talk through what I mean by that in just a moment. Okay, so you guys already understand complements. In fact, you probably first dealt with complements in about second or third grade when you were learning subtraction. So let's go back to second grade. Mrs. Tennyson was my second grade teacher, and she would give us a problem like this. Oh, what's wrong with this stupid thing? There are 10 pieces of fruit. You don't need to write this down. I'm just illustrating something here. There are 10 pieces of fruit in a basket. The fruit, that's supposed to be the word fruit there. It's got an extra I in it. Actually, it's right. R-U-I-T. Okay. The fruit consists of oranges and apples. There are 4 oranges. How many apples? Well, when you answered 6 back in second grade, your thinking was there's 10 things total, minus the 4 oranges, left you 6 apples. Now, what does that have to do with what we're getting ready to say? Let's generalize this concept here. Okay, if I take the total number of possibilities in a counting problem, okay, and I subtract out what I'm going to call event A. Event A here being oranges, then I have to end up with what I'm going to call the complement of event A. So what's a complement, Mr. Black? A complement of an event is anything else that can happen. So if I say have class today, if that's my event, well, everything that else that can happen besides have class is not have class. So in that case, there's only kind of like 2 things going on. You either have class or you don't have class. If I take a 6-sided die, like you play with in Yahtzee, and I roll it, and I say, what's the complement of rolling a 3? It's everything else that can happen. So the complement of rolling a 3 would be rolling a 1, a 2, a 4, a 5, or a 6. Okay, so there are 5 5 parts to the complement of rolling a 3. But that's the idea behind a complement. It's everything else that can happen. So, when we say here, how many apples, right here, if I take the total minus everything else that can happen, I have to end up with how many apples there are. Or I looked at it differently. If I take the total minus the number of ways the oranges can happen, then I have to end up with the number of ways that the oranges can't happen, which would leave me with my number of apples. So this is a concept we've used for a long, long time. We just haven't put it in terms of complements. By the way, this formula works the way I've got it written here, but it also works the other way. If I take the total number of things that can occur minus the complement of A, then I have to be equal with the number of ways that A can occur. I have to end up with A. If I take the total minus the complement, I end up with the number of ways the event can occur. Now, the way that we usually state this concept using mathematical notation is like this. The number of ways event A can occur is equal to, and we refer to the total as n of u. That means the total. It means the number in the universe, everything that can happen, total, minus the number of ways, and I don't know why I put that there, minus n of, and the way we refer to the complement of A is with a prime. So again, in layman's terms, this means the number of ways event A can occur equals the total number of things minus the number of ways event A cannot occur. So let me illustrate one problem. Let me illustrate this property with one problem that's probably about as easy figuring it normal as it is using this rule. But then we'll look at a second problem where this is way easier than trying to find the number just by counting straightforward. So check out this problem. Is everybody done with that screen? I moved it off the screen. So is everybody good there? Okay. This is an example, and it's going to go like this. 2 dice are rolled. How many ways can a 1 not be rolled? Okay, so you guys are a quiet sort, so I'm not going to ask for this answer out loud, but I want you to think about this question for a moment. And my question to you would be, what's the complement of not rolling a 1? And the answer to that would obviously be rolling a 1. The only thing that can happen besides not rolling a 1 would be rolling a 1. So I really have 2 options here. I could list down all the ways that I cannot roll a 1. That's one option. Or I could come over here and say the number of ways of not getting a 1 would equal the total number of things that can happen minus the number of ways that I could get a 1. Okay, so now I've turned this from the problem I had into 2 smaller problems. Now let's think about the total first. Okay, so I'm going to talk to the females in the class here. I'm looking for the total number of things that can happen when I roll 2 dice. So let me ask you something. When I'm trying to figure that out, let's go through our line of questions then. If I roll 2 dice, is repetition allowed? Can I get the same result on both dice? Yes. So therefore I have to draw blanks. Okay. If I draw blanks, how many ways can the first die occur? How many different ways can the first die come up? 6, that's right. And also 6 for the second. Okay, so there are 36 things that can happen when I roll 2 dice. Nicely done, ladies. So I'm going to write that in a little bit different color above the total here. That's 36. Minus. Okay, now let's figure out how many ways I could roll a 1. And I'm going to do that by listing them out. So, I could roll, bless you, I could roll 1 then a 1, or a 1 then a 2, or a 1 then a 3, or a 1 then a 4, a 1 and a 5, or a 1 and a 6. Or, so that would be all the ways I could roll a 1 on the first die. Okay. What are all the ways I could roll 1 on the second die? Well, I've already got 1, 1. But I could get 2 on the first, 1 on the second. 3 on the first, 1 on the second. A 4 with a 1. A 5 with a 1. A 6 with a 1. So if I roll the 2 dice, is there any other way I could get a 1 besides the ones that I have listed here? That'd be it. So how many ways can that happen? Well, here's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 11 different ways to get a 1. So the number of ways I could not get a 1 is that 36 total, minus the 11 ways that I can get a 1. Leaves me 25 ways of not rolling a 1 if I roll 2 dice. That's why I call it coming in the back door, because I didn't just count all the ways I could not get a 1. Okay. Now my other option on that problem was again to list all the ways that I could not get a 1. So then I would have listed things like 2, 2, 2, 3, 2, 4, 2, 5, 2, 6, 3, 2, 3, 3, 3, 4, 3, 5, 3, 6. I could have thought that way until I got them all listed down. I still would have ended up with 25. And really, that might have been about as quick as doing this. But the next problem would not be as quick. In fact, it would take way longer. So, let's take a look at it. And it's going to lead us into another important discussion. I'm looking here at example 2. I'm on page 568. If 4 fair coins are tossed, in how many ways can at least one tail be obtained? Okay, so I'm looking for the number of ways of getting at least one tail. Okay, so if you think about that, if I try to figure that directly, that's a complicated problem. Because I've got 4 coins to consider, so I got to think about all the different ways 4 coins can come up. And let's think about what at least one means. At least one tail, if I got one tail out of those 4, that'd be at least one. So I'd have to count all the ways I get one tail. If I got 2 tails out of the 4, that also would be at least one. So I'd have to count all the ways I could get 2 tails. If I got 3 tails out of 4, that'd also be at least one. So I'd have to count all the ways to get at least 3 tails. And I'd have to count all the ways to get at least 4 tails. So if I figured it directly, I'd have all that work to do. I'd have to add all those up at the end, and that would be a huge problem. But I want us to think for a moment about this phrase, at least one. There's only one possibility that I didn't mention as at least one, and that possibility was 0. The only way I'm not going to get at least one tail is if I get 0 tails. So I want you to put in your notes this sentence. The complement of at least one is 0. The only way you don't get at least one of something is if you get 0 of them. So therefore, anytime we get an at least one problem, we're going to use this formula. The number of at least one of something equals the total minus, and the complement of at least one is 0, so minus the number of ways I can get 0. So again, let me say that again. If I get an at least one problem, I'm going straight to this formula all chapter long. That's where I'm headed. So here I'm asking for the number of ways I could get at least one tail, which equals the total minus the number of ways I could get 0 tails. Okay, so now I've got a direction to head, but I've got 2 smaller problems to work. I got to think through the total. So let's go to Anna. I'm flipping 4 coins. I want to think about how many ways, the total number of ways, those 4 coins can occur. So question number 1, is repetition allowed? Robert, if I flip 4 coins, is repetition allowed?
Yes.
You're correct. Why are you correct?
Because each coin's individual, so if I flip the first one heads, I can flip the second one heads as well.
That's right. That's right. I could get the same result on more than one blank. So, I'm going to have to draw blanks because repetition is allowed. And I'm going to multiply together the number of ways each blank can occur. Okay, well he just said if you flip a coin it could be head, or the other thing that could happen is it could be tail. So the first coin could be head or tail. That's 2 ways it could occur. And there's 2 ways the second blank could occur, and 2 ways the third could occur, and 2 ways the fourth could occur. So when I flip 2 coins, there are 16 different things that can happen. 16 minus. Okay, now I got a second problem. I have to think about, if I flip 4 coins, how many ways could I get 0 tails? Now class, don't overthink this. I flip 4 coins, how many ways could I get 0 tails? I'm fielding that question out to you, and what are you thinking?
1.
What is that 1?
Flip all heads.
That's right. There's only one way you could get 0 tails, and that's if all 4 coins were heads. There's only one way that you get 0 tails. So I have 16 things that can happen total, minus one way that I don't get at least one head. So that has to leave 15 ways to get at least one head. whenever you flip 4 coins. Okay, so make sure you're on board with that formula there. The number of at least 1 equals the total minus the number of zeros. If we would have tried to count the number of ways we get 1 coin and 2 coins and 3 coins and 4 coins, that would have been a much more cumbersome problem. So many problems are quicker to work thinking in terms of complements. Okay, I'm going